So the law of cosines is a really, really amazing and useful tool for solving triangles. Just like the law of sines, the law of cosines does not require a right triangle. So SOHCAHTOA, like the ratios of sine, cosine, and tangent, and using the acronym SOHCAHTOA, is really only useful in right triangles, whereas the law of cosines and the law of sines can be used in any triangle. In particular, the law of cosines is useful for sort of side, 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 and side angle, side triangles. So if you have a triangle where you know all three of the sides, or where you know two of the sides and an included angle, the law of cosines can be really, really useful in actually solving this triangle. Okay. So the formula for the law of cosines is this guy right here. A squared equals b squared plus c squared minus 2bc cosine a. And the most important thing about this whole thing is that the side A and the angle A must be opposite from one another. Right? So, suppose you've got a setup like this, and let's say that you know side B, you know side C, and you know the angle in between them. Wonderful. That will allow you to find this side over here. Now keep in mind, sometimes in problems that things will be called x, or they'll be called y, or they'll change a and b, they'll move things around. The important thing for you to know is that this side and this angle have to be opposite from one another, and b and c are, to be honest, just two other sides in the triangle. Okay? So I've got two examples coming up here, and keep in mind there are sort of two ways that this is going to be used. One way is that they're going to give you b and c and the angle in between, and that will allow you to find the other side. And the other way is that they'll give you the three sides, and you can plug in A, B, and C, and find the angle. So those are going to be the two things we're going to look at here. So in this first example, find the value of x in the triangle given below. Note here, they're basically giving you two sides and the included angle. This is a side angle side triangle. They're asking you to find the side that's opposite from the angle. So this is going to be a really straightforward use of the law of cosines. Here I'm going to use x squared, because that's, and sort of the reason I'm putting x squared there is that I know that cosine 81 degrees is going to go on the very far other side of this thing. I know that this side and the angle that's opposite from it sort of have to be the bookends for this problem. Okay. Now the other stuff here, I'll have 17 squared plus 21 squared minus 2 times 17 times 21, and that's times the cosine of 81 at the end. When I evaluate this, I end up with x squared equals 618.306, and when I square root, I'll end up with x being 24.866. Okay? At this point, you've probably gotten used to me asking the question, is this answer reasonable? Well, it certainly seems like it from the picture. And pictures aren't always to scale, but you could sort of go with the idea that, these angles have to add up to be 180, which means these two things have to add up to be, I guess 99 or 100. And so if you were to sort of split the, if these are, they can't be 50 and 50, but the idea is these two angles seem pretty clearly to be smaller than this one, and the sides are smaller than this one is. Remember, the relationship here is supposed to be that this should be the smallest angle because this is the smallest side. This is going to be the largest side because this is the largest angle in the triangle. Okay? So in this one, there are two separate parts. I want us to find the values of x and y in the triangle given below using the law of cosines. I'll go ahead and walk through the finding of x, and then I'll leave you to finding y on your own. So let's see. If I want to find x, that means I'm going to be putting cosine x at the end of the problem. So what does the law of cosines have to start with? In other words, when I'm solving for x, what do I need to put on the left side for that one? And hopefully you recognize that's 10 squared. I'll have 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of x. Keep in mind, you could have put the 5 and the 7 in any order here. I just put them in that order. As we begin to solve this, we'll have, let's see here, 100 equals, 74 minus 70 cosine x. Let's see, if I subtract the 74 over, that'll give me 26 equals negative 70 cosine x. So the cosine of x is negative 26/70ths. And so now we're going to use inverse cosine to solve for x here. X will be the inverse cosine of negative 26/70, which makes it 111.804 not squared degrees. Okay, and so that's the value of x. Again, in the context of the problem, you can sort of see, and again, we don't know that this is the scale, but you've got the idea that this 10 is like a huge side compared to everything else, to 5 and to 7. So it makes sense that x would be by far the largest angle. So now I'd like you guys to set up the problem for y, solve for y on your own. It should be straightforward, but just make sure that you know how to use the law of cosines. So for y, the opposite side should have been 5, so you've got 5 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of y. Kind of ran out of space there. 25 equals 149 minus 140 cosine y. If we subtract that 149 over, we'll end up with negative 124 equals negative 140 cosine y. So the cosine of y is 124 over 140. Y will be the inverse cosine of 124 over 140, which is going to give us, let's see here, 24.660 degrees. Again, we're not surprised here. That seems to be the smallest angle, and it makes sense. That angle is across from the smallest side, so it makes sense that we would get a small value for that. So that's the law of cosines. There are certainly some more complicated problems that we can see, but this is sort of the basic run-through of the two different ways that the law of cosine question can be asked.